Hello, I am Kermuffin the Frog.
Are you here to do chemistry with us today?
I am chemistry,
That's
the king
great.
of.
King Kermuffin. How great.
Yes,
Please read me
that's very
11.9 then, King Kermuffin. Well, what page is it on?
375.
All right.
In honor of my greatest fan, Martin, I will now change my voice to suit his.
Oh,
So,
King Kermuffin is talented. All right, let's hear it, King.
so acetic acid has a Kb of 2.97 degrees Celsius over molality, and a normal boiling point of 118.1 degrees Celsius. What would be the boiling point of a solution made by dissolving 50.0 grams of CaCO3 in 500.0 grams of acetic acid?
500 grams
Yeah.
of acetic acid. And what's the formula for that?
I'm
What we find in a previous problem. Just here.
No, that's nitric acid.
It was in one of the problems we used this week. If we've gone too far. No, that's not going to help you. There it is.
Acetic
Acetic
acid.
acid. C2.
H4O2. No, we had one similar to this, but it was H6.
Oh, that was ethylene. Okay, so acetic acid is found in the table of some common acids on page 328 in module 10. It's table 10.1. So acetic acid, C2H4O2. All right. So what is the new boiling point going to be? Okay. So we know from the text on page 374, we see formula 11.3, which is this that I wrote on the board. Delta T equals I times Kb times molality. I refers to the number of molecules or ions, right? Delta T is change in temperature. The change in temperature is equal to the positive number of the number of ions or molecules in the freezing point or melting point depression problems that we were doing. We were using the negative I, but here we're using a positive I times this boiling point constant, which we're given over here, right? The boiling point constant is 2.97 degrees Celsius per molality times the molality. Okay, Martin, what is the meaning of the term molality? Molality equals
The number of moles of solute over the number of kilograms of solvent.
So the solvent here is the acetic acid, right? And the solute is the calcium carbonate, right? The CaCO3.
Yeah.
Okay. So
That's easy.
how are we going to figure out how many moles of solute we have? We have 50 grams.
Yeah.
So we're going to use stoichiometry to figure out the number of moles.
Ca is 40.1. Carbon is 12.0.
So oxygen is 16, which is going to be 48 by 3, right?
Yeah.
Okay, so add that up, we get 1, 10, 5, 6, and 100.1 grams per mole, or 1 mole per 100.1 grams. Okay, so we have 50 grams.
We want moles per gram.
Right, so we're going to multiply that by 1 mole per 100.1 grams. You see, we're going to have somewhere around half a mole. So you'll do the math. You'll divide 50 by 100.1. I'm going to write the answer on this side. I hope you can see me still.
It's 0.499500.
Okay, and we want 3 significant digits. So 0.49. What was next?
9500.
4995. Okay, so that's 4 digits that we're going to write down because we want 3. Now we're going to do the rounding. What are we going to round it to?
0.500.
Okay, so 0.500 moles. Right? That's how many moles of that we have. So now we can begin to calculate our molality. We have 0.500 moles. I'm not going to bother writing my units because molality doesn't really have units, as it were.
We have 0.
And how many kilograms of solute do we have? Sorry.
0.5000.
Right. Oh, look at that. That looks familiar.
So that's
Right?
1.
It's going to be 1. The molality. So how many decimals, how many significant digits should I be reporting? I should be reporting 3, I believe.
So that's
Yeah.
1.00.
1.00. Okay. So let's look at our calcium carbonate. How many ions is my calcium carbonate going to break into?
5.
No. We're going to have the calcium and the polyatomic ion carbonate.
Okay.
Right? Okay. 2. Okay. Calcium carbonate is an ionic compound. It's going to split up into the calcium and the carbonate. That's one of the reasons you have to memorize all those polyatomic ions, so you'll be able to recognize when an ionic compound breaks up, it's going to break up into that ionic, polyatomic ion. Yeah. She can speak. So it's 2. So let's set our delta T formula out. So delta T, the change in temperature, which we're going to add to the boiling point, right, is going to be 2, which is the number of ions, times the KB, which is 2.97 degrees Celsius per molality, times the molality, which is 1.00 molality. Molality, goodbye.
We end up with 5.94 degrees Celsius. Since we can only use 1 significant digit, that's 6 degrees Celsius.
No, we can actually use 3 because the 2 is, it's exact. We're not worried about significant digits with it. It's actually 2 ions. Yeah, so we're going to keep it as 3. So delta T is 5.94 degrees Celsius. So what do we do with that? We're going to add it to our boiling point. Okay.
Which is
just like with the other, we added the negative number to our freezing point, which is similar, of course, to subtracting it. We're going to say 5.94 plus 118.1. So since we're doing an addition here, we want to think about precision. So we're only going to be precise to the 10th place. Okay. So we've got 4. 9, 14. So 124.04, which we will report degrees Celsius as 124.0 degrees. Okay. Any questions about that?
No.
All right, we're going to pause and do a separate video for the final one. I hope we'll say Tinker Muffin back again.